Hi everyone. In the given problem statement, we are going to solve a binary tree zigzag level order traversal. So it's a very straightforward problem, like we have to do level order, but there would be a zigzag pattern out here. So let us take the example of this tree 3, 9, 20, 15, and 7. Like we always do, we can have our DQ, and here we are going to solve it using the breadth first search approach. So initially our DQ is going to be empty, or it's going to have a value of root because initializing with the root. We are going to have our result value, which would be empty for now, but also we are going to have one more variable called level, which is going to contain the current level. So initially the level would be 1, this would be the second level, this would be the third level. Okay, so initially the level is 1, so we are popping out this element from the left side of the queue, and you're going to check what elements does it have. So it has element 9 and 20. So there is only one element present in this DQ initially, right, which is the root. So you're going to add that root. And also we are going to create another check in case the level is even, then whatever values that we have, right, we are going to add it in reverse order. So now we are going to pop out 9. So 9 does not have any children, so that's fine. And we are going to have pop out 20. So 20 does have two children, 15 and 7, 15 and 7. We popped it out. So in temporary variable, right, is going to be 9 and 20. But because here, right, the level is 2, right? It's an even level, so we can just reverse it up. So the value would be 20 and 9. So we are going to add this 20 and 9 to our result. Now the level would be at 3. So 15, you're going to pop it out. 15 does not have any children. Popping out 7. 7 also does not have any children. Because now the level is 3, which is an odd level, right? No need to reverse the value. So we're going to add it as it is. So it would be 15 and 7. So here, right, the way we have done it, right, we just use some trick. So we're just doing a level order traversal, but we are checking for the depth, and we are just for the odd cases, we're just adding it as it is. For the even cases, we are just reversing the order, right? So it's always from left to right. We are just doing a reverse back here. So 29. So in that case, it's going to work. So that's the basic idea. Now let us jump to the Python solution. So the first thing that we're going to do, right, we're going to import collection so that we can assign our DQ. So import collections. Now we are going to check in case our root is empty. So if not root, then we are just going to return an empty list. Now we are going to create our queue, which is going to be collections dot dq, and it is going to have the initial value with root. Once that is done, we are going to create a result value where we are going to store the level order traversal. Now also we are going to create another value which is going to be depth, or we can say like height, whatever is you are familiar with. Initially it's going to be 0. Now while our queue has value, we are going to look through. So here, right, we can add a value called temporary variable, which is a temporary list. And also we can increase our depth because we are at the first position. So depth plus equal to 1. So now we are going to loop through. So for underscore in range 0 to length of our queue. So now popping out the first element. So cur equal to q dot pop left, because it's a q, right? We are popping from the left hand side, so 0th, whatever value that is present in this 0th index, right, is going to get popped out. So we are going to add that value temp dot append cur dot val. Now we are going to check if it has any children. So if cur dot left is there, then q dot append cur dot left in case it has right children. So cur dot right q dot append cur dot right. That's the idea. Now for the next thing that we are going to do is, now we are going to check if our depth, in case it's an even value, right, then what we are going to do, we are going to add to our result, but we are just going to reverse it back. So you're going to use a Python operator for reversing, and else just add the value as it is. So res dot append temp, and at last we're going to return our result. So if all things are correct and there are no spelling errors, it should work fine. And the time complexity of it is going to be big O of n, because here we are traversing all the nodes one time. So as you could see, it's pretty efficient. It's splitting 100% of the submission. So that's all for this video. See you in the next one.